Okay, this is a practice problem with energy. When you start a practice problem, or just any problem, you want to write down the equations for energy. In this case, I'm just going to use the two basic equations. Potential energy equals mass times gravity times height. Kinetic energy equals 1/2 mass times velocity squared. And we're going to read the question. With each bounce off the floor, a tennis ball loses 12% of its mechanical energy due to friction. So the loss equals 12%. When the ball is released from a height, so height equals 1.9 meters above the floor, what height will it reach after the fourth bounce? So I'm going to call that fourth bounce. Okay. Height equals question mark. All right. So then we're going to draw a picture. Here's the ball. Here's the floor. And the ball falls, bounce. It goes up, and then it bounces again. And then it goes up, and it bounces again. And it goes up, and it bounces again. Let's see. 1, 2, 3, 4 bounces. So then it's going to go up here. And notice all of the heights are a little bit lower, 12% to be exact, than the previous one. So this height right here is the 1.9 meters. I'm going to call that HO for original height. And this height right here, I'm going to call H1 for height after the first bounce. This height will be height after the second bounce. This will be height 3 for height after the third bounce. And this is the one that we want. We're going to call it H4, or height after the fourth bounce. So this is more of a mathematical a percentage problem. Okay, so because we're dropping the ball, we're looking at potential energy. So this is how it works. Potential energy equals mass times gravity times height. Now, the only things that affect potential energy are the mass, the gravity, and the height. If you're going to bounce the ball, no matter how many times it's going to bounce, the mass will never change. The gravity is not going to change. The only thing that's going to change is the height. So the only thing that can change the potential energy of the ball is the height. So what we're going to do is we're going to look at the height. So if I'm going to write an equation for H1, okay? H1 is going to be, because it loses 12% of its mechanical energy, which would be a 12% change in the height, because the only thing that's going to change this potential energy is the height. So it's going to lose 12% of its height. So I'm going to take 1.9, which is the original height, right? The HO original, minus that 12% of the original height, which is 1.9 times 12%. Okay? And then if I'm going to write an equation, well, let's go ahead and solve that math before we move on. Okay, so I have 1.9 times 0.12. And then I do 1.9, and I subtract that, 0.228 from it. I get my new height. So my H1 is 1.672. Okay? So first, we drop the ball at 1.9, it bounces, and it only comes up 1.672 because 12% of the energy was lost down here in friction. Now that happens to be my new height for the second bounce. So to write an equation for H2 then is going to equal the H1, which is 1.672, minus 12% of that, 1.672 times 12, or 0.12. And we do some math. We get 1.672 times 0.12 equals, then we subtract that from the original of 1.672 equals, so we get 1.471. All right, so this height is H2. And if I'm going to write an equation for H3, now it's going to be 12% less than this. So H3 is going to be 1.471 minus 12% of that, which is 1.471 times 12%, or 0.12. So my H3 is going to be 1.471 times 0.12, and then I'm going to subtract that number from the original 1.471 equals. So I get 1.294 meters. So that height is H3. And I need to know how high h4 is. So we're gonna write an equation for h4. h4 then is going to be the height that the ball is here as it's being dropped or as it falls down for that fourth bounce. We're gonna do 1.294 minus 12% of that. 1.294 times 0.12 equals, so we'll do some math on my calculator here, and what do we get? I get 1.138, so I'm gonna round it to 4. So that's how high the fourth bounce is. These questions are multiple choice, so you want to choose the answer that is closest to this. But the idea here is to look at the proportions. The only thing that can change that potential energy is the height. So whatever percentage we change the height, because it's all multiplication, that same percentage is going to be changing the potential energy. Okay, so that's how we can kind of disregard this idea of the mechanical energy, and we can look directly at the height, because that's what's going to end up changing the potential. So then we just look at the height, minus 12% of it, look at the new height, minus 12% of it, look at the new height, minus 12% of it, and so on and so forth until we get down to the bounce that we want, which is the fourth bounce.